The Next Level Podcast, from Lynn Studios on the Texas Gulf Coast.
Engineering, construction, design, and development. We're building Texas.
Let's get into it.
Hey everybody, welcome back to the Next Level Podcast. I'm Brandon, the CMO here at Lynn Group, and I'll be your host. And today I'm joined with the one and only Sam Bird, one of our professional engineers here at Lynn Engineering. And I'm going to let him introduce himself, but just before that, I want to thank everybody for listening. Remember to like and subscribe, share with your friends, all that good stuff. Spread the word around about Lynn Group, Lynn Engineering, and all the cool stuff we're doing, our projects, and all the awesome people that work here. And with that, ladies and gentlemen, Sam Bird.
Thank you for having me on the podcast. I've been here at Lynn Engineering. It'll be 2 years on 7th of June.
That long already?
Yeah,
wow.
Yeah, almost 2 years already. Before that, I was working in oil and gas for probably about 13 years, 14 years, something like that. And before that, I was doing some engineering in Florida before that. So
okay.
Been in Texas for a long time.
Oh, that's
now.
right. You're a Seminole.
Yeah, that's right. That's right. Yeah. Graduated in 06 from Florida State. So
awesome. Well, we're glad to have you, man. I can't believe it's been 2 years already. It's fun. I remember when I was putting your bio together on the website, my favorite line is that you noodle on the guitar.
Oh, yeah.
Yeah.
Oh, yeah. I'm not professionally taught. I'm just self-taught. So when it got started, my brother, who's the musical genius of the family, he was taking my guitar and playing it in his off time, but he did the bass guitar for jazz band, and he also played percussion in regular band. And I got so mad at him for playing my guitar and complained with my parents. It was just gathering dust up to that point, and my parents were like, well, if you don't want him to play it, then you have to learn how to play it. And so I was like, I'll show them, and took my guitar and basically taught myself how to play. So I would say about intermediate level. But,
awesome.
Yeah.
Well, that's fun, man. I own a guitar.
Yeah. What type of guitar are you on, man?
I have two. I've got a Gibson Les Paul custom Alpine white black hardware.
Nice.
Yeah, it's been my baby for a lot of years. And then I have a Breedlove acoustic guitar.
Okay.
It's got mahogany sides and back with a Koa top.
Yeah, I've got a Ovation Custom Balladeer, 1982, that I use, and then my electric, which doesn't quite get as much love as Epiphone SG, but it's got a Roland G13, I think GR13, so I can't remember exactly what it's called. Guitar synthesizer.
Cool.
On the bridge, so it's a lot of fun.
Well, we could talk music gear, but people are tuned in for engineering.
That's
right. on another episode, we'll talk about that stuff. But cool. So yeah, you're one of our professional engineers here on staff. Mm-hmm. We have several PEs, and kind of tell us what your role is, and how it came to be, and what it looks like today.
How it came to be was that Mitchell was spread too thin. He is the integrator for the Lynn Engineering portion of Lynn Group, as well as the head of the Lynn Steel Buildings portion of the Lynn Group. And basically, he needed someone to come in to take over the structural operations of Bay City specifically, to free him up to be able to work with the other offices. So that's where I came in, and part of that was trying to get up to speed on the process that was used here from inception to final drawings, and then to inspections, and trying to learn all of the calculations and everything behind it. And while I have a background in oil and gas, and my strong suit being steel specifically, there was quite a bit to kind of get caught up on. So once he kind of knew that I was much more comfortable with the calculations, and the mechanics aren't really all that different per se. It's all the same mechanics. It's just a different material, and there's different codes. So in oil and gas, you're looking at API, which is American Petroleum Institute, but with buildings, obviously, most of it's going to be IRC, IBC, and ASCE 07 for the wind specifically. driving most of it. And then most of the stuff that we design here is wood frame construction. So we use the WFCM wood frame construction manual that drives a lot of that sort of design work on the stick framing side of it.
Yeah, so for those who maybe don't know, Lynn Engineering offers several different service lines of engineering, right? We do municipal civil, we do structural and Windstorm certification, we do some land development even, and, there's very diversified all the things that we do, but specifically you're working in the structural side of things, correct? And
Structural Windstorm, yeah.
Yeah. So primarily you're working with home design, home builders, and some volume builders, and also people who are GC in their own projects, that kind of thing. So you probably have quite the client list.
Yeah, so we have everything from small additions to we work with architects. We have a project right now that is kicking off with an architect on Padre Island. That's a little more bespoke than normal. That has different types of materials. So we have concrete walls with timber framing, with floor joists, flat roofs, overhangs, all the rest. So,
wow.
And then we've got
pretty modern looking structure.
Yeah, very, very modern looking structure. Kind of what you would think of when you would think of an architect. This is what this building looks like, several stories tall. But, and then on the other side, you have the really simple, we just kind of want a pole frame style RV cover or a carport. Yeah. And so those things still need signed and sealed. And sometimes it could be a little bit more difficult to get an engineer for those smaller projects. But we like to make sure that the entirety of our community is covered from an engineering standpoint.
Yeah. Fantastic, man. So working with builders, I'm sure, everybody, especially when you're doing custom homes, they want these features that are, make their home stand out. And, we also have a custom homes construction company, so we're well aware of the things people ask for and the things we try to accomplish. In most cases can, everything relies on two things, right? How much time do you have and how much money do you have?
Right.
But as far as the design of it and making sure that it's engineered properly, I think one thing that's kind of in vogue right now that a lot of people are asking about, especially in like the subdivisions and things that we find ourselves engineering in, are cathedral ceilings.
So there's a couple things with that. The cathedral and vaulted get thrown around quite a bit, and there is a little bit of a distinction between them. Cathedral is generally when it's the actual rafters of your roof framing, whereas vaulted, it doesn't necessarily have to be that. You can do what's called false framing, which uses rafters that are not part of the actual deck for your roof, but will actually come in under them. There's a few different ways of framing it, but the biggest thing is that normally when you are doing conventional stick framing, you lap your ceiling joists on top of your rafters, and that keeps the triangular sort of frame. And what happens with that is that it keeps your rafters from trying to kick your walls out. The other part is that it's now introducing sag into your ridge board. And so the only way to really do that is to take the ridge board and create a structural beam from it. And so you end up having to not only size that beam to carry half the load from the rafters, the other half is being carried by the exterior walls that is supporting it. But then you also need to have columns on each side of that ridge beam to carry down into your foundation. And
that's the point of all this, right? You're transferring load from top to bottom into the foundation.
Right.
And, some people forget that, the wall is there for a reason. It's holding something up possibly. Or there are walls that are not structural. There are, within the interior of the home, stuff that can be moved and whatever. But there are some things that, that's where it has to go.
Absolutely.
So,
and the easiest way to figure that out is just go in the attic and figure out where the ends of your ceiling joists are. Most of the time, where they're lapping over, that's a load-bearing wall. You can't remove that. If you do, you have to support it somehow. Most of the time when people are trying to knock down load-bearing walls, then we're going to go in with a structural beam and either put the structural beam underneath of it, or we're going to have to cut back the ceiling joists and run beams and then use hangers so that you still have a flush ceiling. Those are kind of the two ways to frame that out. With the kind of circling back to the cathedral ceilings, so you can either support the ridge board from a structural beam kind of in the false framing, or you can scissor the rafters, kind of lap them over, and then those will get braced to the true rafters, but you'll still need a structural beam up at the ridge itself. So those are kind of the two different ways you can do it. You can either have the structural ridge in the false framing or in the true roof, and then either scissor the rafters on the second option, or brace the true ridge off of the false ridge on the false framing.
So I know as a builder is building the home and the homeowner at the end, that will be the end user of the product, they're both going to be concerned with timeline and budget to accomplish those two things. Is there a more cost-effective way of doing it, or?
So there's not really, because the geometry is really kind of what drives the size of these members. Obviously, it's a lot harder on the budget and the time if it's a cathedral ceiling, say in an exposed area like a back covered porch, because then you either have to wrap the beam or you have to get pressure treated, which obviously makes it a more limited item to try and procure. Inside, you have a little more option. You can kind of do whether it's treated or not. It's kind of insignificant. You could get LVLs versus glue lambs. So there are some options, but most of it's going to be generated by the dimensions of the span of the beam and how much tributary area. So basically how long the rafters are that are framing into it.
So for the non-builder, from that perspective, it's not just, lift the ceiling up, right? It's
right.
It's a lot more complicated than maybe just not hanging sheetrock a certain way, right? Right.
You're changing the load path and the way that the walls are acting in a support manner. Once you take out the completely horizontal members, now you have to find a way to combat that inclination for the rafters to push out onto the walls. And the only way to really do that is to actually let it only be vertical with a ridge beam.
Okay. Are there certain spaces within a home where it's, say, more preferred to do this versus others?
Yeah, so on a lot of the homes, you'll see the cathedral type ceilings in the great room, kind of the kitchen dining area, those shared spaces. It's generally considered a main feature of the house. So those larger spaces are where you'll generally see it. Every once in a while, you'll see it in a bedroom. But most often it's in those common areas.
When you do a cathedral vaulted, what else do you need to consider from a builder end user perspective?
It's going to be generally a lot more expensive than doing a flat ceiling. The other thing to consider is, and I've not seen this too much, but it has happened, is plate heights. So plate height, for those that don't know, is essentially where the top of your wall sits. And it generally drives how tall your ceiling is. So 8-foot plate height is an 8-foot ceiling kind of deal. But every once in a while, you'll run into, they'll have a cathedral ceiling, and you'll have a 10-foot plate height on one side and an 8-foot plate height on the other side. And you have to try to make that geometry work. And the only way to do that is either to shift the ridge over, or to do two different slopes. And while two different slopes is not very visually appealing. And so you have to kind of consider that. And then obviously there's the geometry. If you've got more than one story, how does that framing affect the floor above? You can't really have a flat floor over a cathedral. So
In a vaulted or cathedral situation, have you seen people introduce glazing into that mix as well? Say a skylight or something of that nature?
I've not personally seen it yet. We do have one that there was an option for it. So that's not really going to change too much of the ridge beam itself. Okay. It's going to change the local framing around the feature that you're trying to add. So with like a sunlight, you have to make sure what size it is and what the rough tributary area of that's going to be. And then normally it's somewhat small, so you can get away with double framing the rafters on each side. And then whatever your opening is, the same size is basically used to kind of tie the rafters in horizontally. Mm-hmm. And then that's kind of how you're going to frame out that portion of the roof. So,
yeah, I'm thinking from all the features people want to add in a showpiece statement room or whatever. Mm-hmm. There's also, incorporating a chimney into a vaulted ceiling as well, right? Mm-hmm. You're going to have a fireplace in the great room with the vaulted ceiling, and I guess could possibly add some support.
Yeah, so the fireplace is always an interesting one because you need to make sure that both sides of your beam are supported, but you also need to make sure that your chimney can go up through the roof.
Right.
And so a lot of times, the fireplace is centered on the room and the ridge beam is also centered on the room, you have to get a little creative with how you do that. And oftentimes what will happen is the vents, they can actually be kind of maneuvered around the ridge so that visually from the outside it looks like it's just going straight through the beam, but the reality is that the vents are actually going around it.
The more you know.
Yep, absolutely. So that's generally how that's tackled. You could potentially create a frame within the veneer of the fireplace to kind of bring it down. That's generally way more complicated than the first option, though. So most people will opt for the first option.
Yeah. So. Very cool. So what else do you see people doing? Real quick, I'm sorry, let me back up. So we're talking the vaulted and cathedral ceilings, and I understand that changes kind of the framing with the trusses and all that. Mm-hmm. In the high wind areas of Texas where we do a lot of work, mm-hmm. how does that affect as far as like clips and straps and windstorm type stuff that's also required in the area? Does it change any of that at all?
So there's not really a huge change because basically when we're doing the windstorm design, the wind pressures on the roof don't really change whether it's cathedral or traditional flat ceiling. Uh-huh. So we always looking at the ridge strap to keep the rafters from lifting up and splaying away from the ridge. Uh-huh. Whether that's a beam or a board, just a framing member, we still have to make sure that we're strapping from rafter to rafter to keep that from happening. It's kind of similar to the old traditional collar ties, but with collar ties, the prescriptive method in IRC, the International Residential Code, is only good up to 100 miles per hour. So a lot of people want to use the cord ties, but you would actually have to go through and calculate, and most of the times it will exceed the 16-inch spacing that most stick framing's on there. And so that's why we call out the strap at the top. And then the rafter to the double top plate is the other connection. So the ceiling joists aren't generally considered in that uplift calculation. So whether you go with a flat ceiling or a cathedral ceiling really doesn't change that envelope.
Okay. So now moving on, what other type of custom or interesting, just anything other than standard features are you seeing right now that we're doing a lot as far as design goes? So
design-wise, from a windstorm perspective, the thing that I always see is how can we jam more windows onto this? And that's always...
Everybody wants natural light.
Everyone wants natural light. Everyone wants a good view, right? So everywhere along the coast, everyone wants to see the ocean, the palm trees, and all the rest. So the difficulty with that, though, is there's two different methods of evaluating a wall, a shear wall specifically. And that's the perforated wall method and the segmented wall method. And the difference between the two is really in how you apply your sheathing. as well as how you apply your hold downs. With the perforated wall method, you treat each wall braced panel as one continuous unit. So there's one uplift at one corner that is trying to overturn that shear wall. And each window or door is basically like poking a hole in that shear wall. So the more windows or holes you poke into that shear wall, the weaker it gets. Segmented shear panels are essentially if all of my joints on my shear panels were lined up to allow it to each panel to rotate on its own. So you end up with a lot more hold downs, which is generally not preferred, but it does reduce the load somewhat. It's generally a lot cheaper to go with the first option, which is what we normally do our calculations with. But going back to how do I get as many windows onto my wall as possible, there are multiple methods. So part of the strategy that we use is using stronger sheathing material. Normally 7/16 OSB on the outside is kind of the go-to. Everyone does 7/16 OSB unless told otherwise. And so we can use thicker material. We can use plywood versus OSB. We can use interior shear walls to kind of break the amount of supporting span that shear wall is seeing. And then, of course, you get clever with trying to make sure that your windows are either smaller, they're spaced out differently, that sort of thing. With the perforated wall method, the tallest opening is what drives the size of holes you're poking in your shear wall, essentially. Okay. So if I've got an 8-foot door, it doesn't matter if my window is 3 feet wide and 5 foot tall, or 3 feet wide and 6 feet tall. The 8-foot door is what's driving the height of all the openings. So if you can bring it down to like a 3 foot, 6 foot 8 inch tall door, then if that's your tallest height, now you've made all of your sheathing percentages go up, because now all of those holes are now smaller.
Got it.
So that's kind of another way to do it. People like to use transom windows, and that kind of increases that height. And so I try to get people to move away from transom windows as a result, when you're running into the issue where you just want more windows width-wise. So,
I'm thinking of some designs I've seen, and one, not being an engineer, I'm just looking at things, and it's Greek to me most of the time, but I see interior shear walls a lot, specifically on like the walls around the garage. Are there other preferred spaces within the home that can be turned into interior shear walls?
Right. So when you're trying to utilize interior shear walls, you're trying to use walls that are continuous as much as possible. We're allowed roughly about 4 feet to deviate from that line and still consider a single braced panel, which with a garage, it's pretty simple because you normally have that whole width of that wall, and you're normally trying to do a vapor barrier from the garage into the rest of the living space anyway. So it makes a naturally easy transition into a shear wall. The other part of it is location. So you want to have your shear walls are essentially your supporting walls for the wall getting hit by wind. And so if you can try to spread that area by getting a interior shear wall more towards the middle, or even close to the wall that you're having issue with, say, this side you're having a huge amount of windows and the other side you're not so much, then maybe getting into your shear wall near your perforated wall it will be more beneficial. But a lot of that's really going to be driven by the floor plan, the geometry of the building itself. And so that's kind of the things that we have to take into consideration. And then those walls also, we have to take openings into consideration. So
doors and that kind of thing.
Right. Probably not windows and doors, but
not many windows inside. I've seen it.
It does happen. I
have seen it. But most people don't want a window from their dining room into their garage.
That's true.
Unless they just have like a really sweet classic car in there or something that they want to make a conversation piece out of. But, well, very cool. So I noticed recently we've done a few different things that aren't as common around the area. We got into the post tension game recently. Kind of walk me through what makes that different than your standard or what we traditionally see.
Yeah, so traditional slab on grade is just you set your rebar in there, and then you make sure that the rebar sizes and spacings are correct, and then you pour your concrete in there, and once it cures, it's good to go. The steel, so that's the thing about concrete, is that it's always a composite. And what I mean by that is it's always comprised of more than one material. You always have to have steel with it because concrete is very poor in tension, or essentially pulling force. And so that's where the steel comes in. Concrete is very good in compression, not so much in compression, obviously. It's like a pushing force. If you take your hands and push them together, it's compression. So what happens is that steel can get really expensive. And so they utilize what's called the post-tensioning. So with the post-tension slab, they sleeve cables inside of the concrete, and once it gets to partial strength, what they'll do is it's actually formed. If you've seen the truck beds that kind of have an aluminum bed and it's kind of humped over, this is a very similar concept where you're essentially trying to deform the concrete upward by trying to straighten out the cable. So when you pull on those cables, it's essentially trying to move the concrete upwards so that when you actually start loading it downward, it's trying to go back to a neutral position for the concrete itself. And so with like the aluminum truck beds, since they're humped up and you load them down, they'll actually flatten out to give it essentially more capacity, because now it has to go that much further before it actually bends down into a failure position, a sagging position essentially. So with going with the post tensioning, you can get away with a lot less steel, which helps to reduce the cost for slab construction. Now there's definitely pros and cons to both approach. With a post tension slab, obviously you've got cables that are under extreme amount of tension, so those have to make sure that the ends are properly maintained and covered, so that way they don't corrode. And you lose. There's two different failure mechanisms for it. So one is just it corrodes and it loses tension. It just kind of goes limp, and you're no longer getting that post tension benefit from it, which means that you might run into issues with the slab cracking there. And then the other part is more of a catastrophic failure, which is the cable snaps, and that's definitely something you don't want to run into. But if the cables are tensioned correctly and they are maintained and covered correctly, then there's really no noticeable difference in the performance of a regular slab on grade to a post tension slab.
And as far as longevity, it's going to last just as long, or
right? So the American Concrete Institute, ACI, they give us pretty strict parameters in the codes to make sure that anything cast against earth has a 3-inch clear cover, because concrete is semi-porous, and so you want to have that buffer, that concrete buffer, to make sure that the water's not getting to it to corrode it. And it's basically the same things with the heads of the post-tension cables. As long as you're maintaining a clear cover that's appropriate for it, then you won't run into corrosion issues with it.
Okay. What other fun stuff are we working on lately? Anything come across your desk? It's just like, okay, that's different.
Obviously, I always like to see the ICF houses come across the desk, the insulated concrete form, for everyone out there who doesn't know what ICF is. But those are always interesting and fun projects to work with as well. Yeah.
The construction company recently built one in Port O'Connor, and I'm sure we engineered it too. That's an amazing home. We talked about it on a recent episode as well. And, I went to go take photographs of it a while back, and it's just, just walking through it was surreal.
Right.
It's because he did the stained concrete floors and concrete countertops. He went all in on the industrial concrete look, right? I mean, it was cool. And it was also like 100 degrees outside and only like 60 inside the house, and he didn't even have the power on yet,
Right.
It was awesome.
So ICFs is always interesting because you have the styrofoam on the outside and the inside that help from a sound insulation and a thermal insulation standpoint. And then you've obviously got the concrete center of it. And so, yeah, that really helps to kind of keep the thermal barrier very static. So it does help a lot when you're trying to keep the heat out or the heat in the wintertime. So, yeah, I haven't been back to that particular site you're talking about in Port O'Connor since they put up the light gauge steel studding. So I haven't seen it finished out. But
it's a wonderful finished product. Trying to think of other projects lately. So, I mean, mostly you're dealing with, single family residential. What else comes across your desk beyond that?
So things that come across my desk, one that is kind of gained popularity is Barndominiums. So there's two different style of Barndominiums. And
there's a custom home with steel studs, and then there's a pole barn, right?
Well, yeah, I do the quotes for barns because there's two different materials that kind of drive the idea of the barndominium, and one is pre-engineered metal buildings that Lynn Steel Buildings does. The engineering side, we do the foundations for those specifically, and then there is the pole barn, which is really pole framing. It was just used for a lot of storage barns in the Midwest, and that's kind of how it got its common vernacular of a pole barn. But the actual framing method's called pole framing. And it's not a new method, but it is new in the coating world. So the IBC, it kind of references other literature, but it doesn't really truly cover pole framing specifically. So there's still a lot of work to be done in the research and development aspect of codifying pole barns, but the mechanics behind it are pretty simple. So basically with the pole framing, it's kind of hidden in the name, is that you use a bunch of poles and it's a lateral frame. And so what I mean by that is it's essentially supposed to take your wind loading and transmit it along what are called your wall girts. So like traditional studding is vertical, but in pole framing it's actually horizontal. And so that takes your load and transmits it to those poles that then go into the ground. And they're generally pretty shallow, 4 to 6 feet. But the kicker is that it has to be natural grade. And the reason it has to be natural grade is because that's soil that's been out there for who knows how long, 20, 30 years. And that helps to ensure that it's consolidated, which is a fancy word for saying that it's compacted. Yeah. So with that being said, we do see a lot of people trying to do multiple stories inside of pole barns, pole framing. And that's not really what the true intention of those frames are. The 4 to 6 foot embedment length doesn't really give you the ability to put floor loading, vertical loading onto those frames. And so that's kind of one of the things that we're struggling to try and get across to people, is if they want multiple stories, they really should be looking at like steel buildings with a mezzanine built in, or to do traditional stick stud framing. So, but yeah, those are two things that I come across my desk quite regularly that are kind of outside the normal realm of engineering, at least broadly speaking. They're quite common for me. Right.
So I'm in this Facebook group, and I thought I was going to swear Facebook off a long time ago, but anyway, it's all about Barndominiums is, the group itself. And truthfully, I got into it for market research, and I've just stayed in it because it's entertaining now. But all these people are posting. It's a nationwide group, people all over. They're like, oh, I just got my plans back from the engineer, and I went to find a builder, and it's just, I can't believe how expensive it is to build. It's just a pole barn, and they show a picture of a rendering, and it's nothing. It's not a pole barn. It's a custom home with metal walls and roof. And it's like,
and that's the other side of the pole framing is that actually, that does remind me. I have one that's come across my desk specifically with this issue. Is someone wanting to do pole framing, but they're wanting to use hardy plank. And the problem is that hardy plank needs to be fastened to paneling, structural paneling, and the combination of the two are too heavy for wall girts. So with pole framing, you're generally going with like a corrugated steel panel on the outside, very light, but very rigid. So something that's more akin to pre-engineered metal building. So when you start to use these heavier materials on the outside, well, those heavier materials have to be supported, and that support framework then becomes a lot more stout. Traditionally it's just 2x6s formed in a lattice work of vertical or horizontal or both in terms of orientation to kind of help you fight that flexure of the wind trying to push it in on the sides. So when you start to add in,
What do you mean hardy's not just decorative?
Yeah.
I know, right?
There is a structural component to it. We try not to utilize it as such, but the weight is definitely a consideration. All materials have weight that you have to consider. So
Right, that's the point I was driving to, right? So, I mean, a lot of times, educating people on everything you add affects the calculation in one way or the other.
Right.
It's not just stick this on the outside because it's pretty.
Right.
And it's interesting, you see these homes, because the farmhouse thing's big right now. So everybody wants the board and batten. And they want a lot of windows with the board and batten, and they want to do it for, they want a 3,000 square foot home and they want to build it for $250,000. And
right. And you have to, it comes down to that how economically feasible is this, right?
Right.
A lot of people want as much as they can for as little as they can, right?
But, I mean, and it's understandable, right? I mean,
absolutely.
And people who don't do this every day, they don't know these things. Right. And that's kind of where we come in. We have to kind of guide them and explain some of this. And I say this all the time, but, we do this every day for a lot of these people. If they're not a general contractor, they're going to do it once or twice in their entire life. Right. So we don't expect them to have the answers. Right. But, a volume home builders, you would hope, knows these things.
Right.
So,
but even some of the contractors, you have to start somewhere, right?
Right.
And so a lot of times they'll have a lot of questions that they need to ask because they're just getting started as well. So we do try to kind of explain what is driving our decision. Every once in a while, we can have some flexure and try to figure out an alternative method to try to implement something.
I'm thinking of one, this may predate you joining the team, but there is a coastal home that we did recently within the last few years. We engineered it, and it was right on the water, and they wanted a bunch of windows facing out to the water, a ton of glazing, right? And it ended up, it's a stick-built home, and it had to add, I think, one or two steel members. There's a few beams in there to transfer some load so that you could have quite a bit of impact glass overlooking the water, right?
Right.
And it is a absolutely fantastic, beautiful home. And it took some real creative problem solving to make those calculations work, from what I understand. But
I bet that one does sound like it was a bit before my time, but I can kind of envision the process. So generally speaking, when you have an opening in a stick frame stud wall, a traditionally framed wood wall, you're basically cutting off your vertical supports, right? And so what you have to do is you create what's called a header, which is essentially just a beam that gets pushed out towards the framing that you do have. And so that header is supported by jack beams, which are literally right underneath the header. And then those are framed right outside with a king stud, which is essentially a full height stud that is joined to those jack studs that are connected to that header. So with a whole bunch of windows, you've got a much longer header. And so what's probably was driving that was, how do we get something that's not tall, that fits in the diaphragm of the wall, but is also strong enough? Well, steel's obviously going to be much stronger than wood in terms of bending stress. So they probably did a frame out with the steel. How they connected it, I don't really know. That's kind of the magician side of it, is how do we get this to work with the wood framing. But that's likely where the steel beam came in, was in the header.
Yeah.
So
It's very cool. I think there's a case study on it on the website. I have to go back and read it. But it was a very creative solution that made the customer very delighted at the end of the day. So they got their view that they wanted. So, well, man, I appreciate you taking the time. Is there anything else interesting that you can think of as far as single-family residential home building that you've seen come across your desk the last couple of years?
I'm sure there is. And I'm sure this won't be my last time on the podcast.
No.
So we'll save it for next time.
We'll save it for the next one. Okay. Well, I'll do a few rapid-fire questions at the end of all of these.
Okay.
So, who makes the best tacos?
That is a very tough one. There's so many good Mexican places in Houston.
Yeah.
It's because I live a lot closer.
Yeah.
So right now, like, the closest one to me that is my go-to is Jimmy Changa's, which is the same company as Gringo's.
Yeah.
So I go there a lot. But man, El Tiempo is really really good.
Nice. All right. What are you reading right now?
What am I reading? I don't know. Our book club just finished.
We just finished Atomic Habits.
So nothing right now. I need to be kind of poked and prodded to read.
Yeah.
Most of the time, I'm just reading bland technical documentation because.
That sounds riveting.
Oh, absolutely for me. But yeah,
I had Celeste on earlier, and I said, "What are you reading right now?" She's studying for. She calls it the SHRM, the something human resources.
Okay.
She's studying for a test. She's like, so she's telling me all about these textbooks, and I was like, man, I hope somebody's got a better answer than that today.
No, I don't. I'm not an avid reader. My wife is the reader of the two of us. So.
Well, you have a pretty significant commute, so what do you listen to on the drive?
Oh man, I listen to a lot of synthwave.
Okay.
And chill step.
Okay.
But other than that, I find myself quite often just kind of decompressing, being with my thoughts in silence as well.
Nice.
So it's kind of a mixture of things. So every once in a while, I'll get caught up on some of the YouTube thing. Just not watching it, but listening to it. Just kind of to that way I've kept more in the loop on things. So.
And the Next Level podcast, obviously.
Absolutely.
Let's see. As a guitarist, what's your favorite song to play?
Favorite one to play is the artist is escaping me right now. Supermassive Black Hole.
Okay, yeah. Soundgarden, right?
No,
that's not them. Who is it?
Why can't I think of their name? But anyway, the song's called Supermassive Black Hole. That's a lot of fun to play.
Yeah.
So you should check it out.
No, I know the song.
Muse.
Okay.
That's who it is. But anyway.
All right.
That's probably my most fun.
Who's your favorite guitarist?
Favorite guitarist? Man, that is a tough one to nail it down to just one. I would say if I could only listen to one person, it'd probably be Antoine Dufour.
Okay.
And he is a solo acoustic guitarist. I think he's out on his own now, but he used to be part of Candy Rat labels. So the same one that I think became famous because of Andy McKee.
Andy McKee, yeah.
So he has a similar style as to him.
Slaps the guitar and all that.
Right. He uses the
percussive
guitar. Yeah. But he is absolutely amazing to listen to. So.
There's another one that I really like too. Have you heard of Luca Straganoli?
Yes.
Yeah.
Yes. Yeah.
His covers are pretty sweet.
I have some of his albums.
Yeah. Andy does a lot of original stuff. But Luca does a lot. I'm sure he does original stuff too, but he does a lot of
covers.
A lot of contemporary covers. I mean, people find him I guess, searching for the song they're looking for, and they find him, and then they find his original stuff too. But cool, man. Well, what's for dinner tonight?
Oh, I don't know yet. I've got to dial in with Carla to figure out.
All right. Well, hey, thanks for taking the time.
Absolutely.
I
Thanks for
probably
having
took
me.
more than 20 minutes of your time. But,
Oh, you're good. You're good.
I really appreciate it. It's cool to have some technical speak on the pod. So we'll have to do this more often.
Absolutely. Yeah.
And for all you listeners out there, if you're a builder or, you know, a homeowner or kind of dreaming up your own project in the future, if you have questions, send them in to hello@lyngroup.com, and we'll find the right person on staff that can answer those. Most likely going to be Sam. I'm joking. Because he's already fell victim to the pod once. We can have him back.
That's right. That's right.
But yeah, again, like the episode, share it with your friends, subscribe to the podcast. As what's Mitchell say? Smash the like button and ring the bells or something. I don't know. Every time he's on, he says it, and I'm just like, God, that's so corny. But he's probably stealing it from somewhere. Again, thanks for listening. That's Next Level.